Who is that music, huh? Sure. Hello, 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 hello. Hello, guys. Hello. Welcome, one and all, to another new live stream. Today, we are gonna review our Leetcode contest 462. Sorry for being late. So, we'll start with our first question of the day, which is flip square submatrix vertically. The question is, you are given an m cross n matrix grid where three integers x, y, and k. Uh, the integers x and y represent the row and column indices of the top left corner of the square submatrix, and the integer k represents the side length of the square submatrix. Your task is to flip the submatrix by reversing the order of rows identically. Return the updated matrix. So what they are asking is, we have to flip the submatrix. For this, what we have to do is reverse the order of the rows. They have given us an example: 1 2 3 4 5 6 7 8 9 10 11 12, and then they have given k is equal to 3, the submatrix length, like the submatrix length, which is 3 cross 3. x is equal to 1 and y is equal to 0, which is our row and column indices. So from x is equal to 1, which is our second line, and y is equal to 0, which the first element with y is equal to 0 and x is equal to 1 is 5. So 5, 6, 7, 9, 10, 11, 13, 14, 15. This matrix should be flipped. So the 13, 14, 15 should be in our first line now. I mean, first line of the submatrix. And 5, 6, 7 should come to the bottom. So our output, like, that's what we need in our output basically. So the question is, okay, let me just copy down this thing. 1, 2, 3, 4, okay. What is the name of the question once again? Flip matrix will give it as flip submatrix. So the question goes this way. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. There's a given matrix. And what they are saying to us is they have given us x equal to 1, y equal to 0 from there, and k is equal to 3. K is the length of the square matrix. So x equal to 1 and y is equal to 0, the element is this. These are element 5. So from here k is equal to 3, 1, 2, 3, and 1, 2, 3. So this will be our submatrix, the one highlighted in the red color. This is gonna be our submatrix. So in our output, what we have to do is we have to just reverse this matrix. Our output is gonna be somewhat like this. And first line will be unchanged, 1, 2, 3, 4. And the last this one, the last rows are like this 8, 12, 4, 8, 12, 16. This also gonna be the same. The last column. Now what is gonna change here is the last line, the last row. 13, 14, 15 will come here, and this is gonna remain same because this was the middle line, and here 5, 6, 7. So the whole matrix is flipped. This submatrix is flipped here. So now we'll see how to solve the question. Okay, Prithvij, will come to the second and the third. Second one was also easier. We'll let you know. Just we'll go in an order. So we'll go to our intuition up. We'll go to our intuition. Here we are given a square matrix. We are given a square submatrix, and this is given inside a in a large square matrix, larger square matrix. We need to flip this based on xy and k. X, Y, just a second, Y and K, where our X is rows, Y is columns, and K is the length of the side, or whatever, the length of the submatrix. Now, this is basically the question. It's actually easy itself. We'll go to our approach. What we'll do here is, first step, what we'll do is, we'll take the top left corner of square matrix, of square submatrix, and we'll take it as x comma y, and its size as k cross k, since it's a square matrix. Then we'll have to flip it vertically. For that, what we'll do is, first step, so for flipping this vertically, what we'll do is, firstly we'll iterate the top row of the submatrix. Iterate the top row. Of submatrix to its middle, which is k by 2 rows. And after this, for each row I, we will, in the first top row, for each row I will swap it with corresponding row will swap it with corresponding row from bottom half. And then what we are gonna do is, after this, we'll take each swap is done column by column, and it is done from y to y plus k minus 1. So if our y is 1 and our k value is 3, it is gonna go from 0 to y is 1, okay, sorry, 1 to 2. For example, if our y is 0, k is 3, means it is gonna go from 0 to 2. So We'll go to the code, and this gonna be a code. We'll call a function first for the, we'll iterate for half the rows as I said earlier, top row of the submatrix, which is k by 2 rows, and then there's a for the first half, top half of the rows, and this is a row index from our top half, and there's a bottom index, bottom index bottom half row index, I mean. And next again, to swap, we'll run another loop, swap loop, and this basically are swapping every one of, then this is running column by column, C, column by column, and this is our final answer. So we'll just run this code. So it does run, and we'll submit it to check if it passes all the test cases. So it does pass every single given test case. And so yeah, we'll check what is the time complexity of this and the space complexity. Anyone in the chat, what is the space complexity and time complexity of this? So our time complexity is gonna be outer loop k by 2 iterations, and then inner loop k iterations. So the total operations is O of k square. Time complexity is gonna be O of k square. Mostly, what is the value of k as a constraint here? I'll just check it. M minus, okay, M is 50, so k can't be more than that. M cross n is 50. Whatever the whatever the constraints are, this is gonna be a standardized time complexity, which is O of k square. And our space complexity, since we are using very few variables for swapping and all, and we don't even use an extra data structure, space complexity is gonna be O of 1. So this is our first question. If anyone has any doubts, please let me know in the comments. So we'll go on to our second question. Maximum k to sort a permutation. You are given with an integer array nums of length n, where nums is the permutation of the numbers in range 0 to n minus 1. You may swap the elements indices I and j only if nums of I and nums of j is equal to k, where and denotes the bitwise AND operation and k is a non-negative integer. Return the maximum value of a k such that the array can be sorted in decreasing order using any number of such swaps. If nums is already sorted, there's a special case. If nums is already sorted, return 0. A permutation is a rearrangement of elements in an array. They have also defined permutation here. So we'll just see one example. We'll see an example of sorted first. So you can see the example of the last one, the third example here, 3210. So the array is already in sorted order. So output should be return, like it should return 0. So the output is gonna be 0. Now we'll check the other options. Which is gonna be our first example, which says input nums is equal to 0, 3, 2, 1, and output is gonna be 1. If k is equal to 1, if we swap one number, that is the number at indices 1 and the index value 3, if we swap these two, it will result us in a sorted order. So we'll go, what is this? Max k to sort permutation. So our question number 2, max k to sort permutation. Now for this, what is the okay, there are two conditions. One, swap, so not swap. First condition is return 0 if sorted. If not, we have to find the number of swaps. That is what is given. Maximum value of k such that array can be sorted in non-decreasing order. Non-decreasing order is basically increasing order. Max k for non-descending. We'll go to our approach next. Sorry, we'll go to our intuition. We should actually look for our largest k value, which is the maximum value of k, where we can sort this permutation, and for this we are using swaps. So what we'll do is, we can take like this, nums of I and nums of j should be equal to k. If we simply take like this, half of the question is actually solved with this one line. Now after this, what we'll do, that this means that if we are given with k, elements can only be swapped if both share exact same and logical AND result. This is logical AND. So both should share, both logical AND result same. There's condition for swap only if And then next one is, if large k value, it will become more restrictive, or it will become more restricted, because there will be only few pairs which will satisfy AND condition. Few pairs satisfy AND condition. Now after this we want the max k. We want max k. For sorting. Now if already array is sorted is a second case, what we have to do? If sorted, this done. Next, if sorted, return 0. So yeah, these are intuition basically. Now we'll go to the approach quickly. First thing is, what we have to do is we have to check if the array is already sorted. Check if sorted already. And if sorted, yes. If yes, then return 0. In our next step, what we'll do is we have to find the elements that need to move. Find the elements that are needed to be moved. So for this, what we'll do is we'll compare nums with sorted nums. Nums is our array, sorted nums is the sorted array. We'll compare the array and the sorted version of the array basically here. And wherever nums is not equal to sorted nums of I not equal to sorted nums, I'll just write it as s nums, so nums or else of I, we swap to the correct position. Swap to correct position. Done. So next, the whole base of this question in our third step, bitwise AND operation. I mean bitwise AND, we'll keep a restriction here. Bitwise, and this is our restriction here. So if the numbers are misplaced, they must be connected through swap, and their bitwise AND must be at least the chosen k. So the k value and should, like the bitwise operations result, it should be minimum of k which we have chosen. And bitwise, I'll just simply write as bitwise of misplaced numbers of connected same swap group minimum, it should be k, min value is k. Done. So next step, maximum k that allows all required swaps is the bitwise AND of all misplaced. So max k, this one step within this, sorry, this one step within bitwise AND restriction. This is our first step. In our second step, what we'll do is max of k is what is the bitwise AND of elements, is bitwise AND. That's all is this. And yeah, that's all is basically our approach. Now what we'll do is we'll go to the code, and yeah, so this is basically the code. Now what we'll do is n is okay, our this is our sorted nums, you all know what it is. Sorted array, and if sorted return 0, if sorted return 0. The previous if condition is that I wrote it one line below, just understand it guys. Yeah, this is initialize k as all bits set. Now you will run a for loop for each misplaced element, for each misplaced element. And we'll update, what will update here, we'll update the k with bitwise AND, k with bitwise and here what we'll do is we'll restrict our k to only bits that are common in the misplaced, to common bits. Common bits in the misplaced elements. This is our final value, this is our answer, which is the largest possible k value. We'll submit this, and this works perfectly well. So this is our second question. What is the space and time complexity of this question? Anyone in the chat guys? Anyone in the chat guys, what is the time and space complexity? Very easy. Time complexity of this is, you can't get a easier question than this for time complexity. So first one, sorting O of n log n, and then comparing sorted version, sorted, and bitwise AND, doing a bitwise AND operation, doing a and d for every element of that array. It will be O of n. So this overall time complexity is equal to O of n log n, taking the dominant term here, which is n log n. Now the space complexity, which is storing our array, store array O of n, and then all the other extra spaces will be O of 1. So our space complexity is gonna be O of n, order of n, taking n, this is n, order of n. So I hope everyone are clear with this. We'll go to our third question. Maximum total from optimal activation order. So okay, you are given two integer arrays, value and limit, both of length n. Initially elements are inactive. Just a second, guys. Sorry. Yeah. You are given with two integer arrays, value and limit, both of length n. Initially all elements are inactive. You may activate them in any order. To activate an element at index I, the number of currently active members should be strictly less than limit of I. When you activate the element at index I, it adds value I to total activation value, that is the sum of value I for all elements that have undergone activation operations. And then after each activation, if the number of currently active elements becomes x, then all elements with all all elements j with limit j less than or equal to x become permanently inactive if they are already active. Return the maximum total you can obtain by choosing activation order optimally. So yeah, uh, they say that they are given three conditions to activate it, and we have to return the maximum total we can obtain by choosing a optimal activation order. We can choose it optimally. We have to give them the maximum total we can obtain. Only one single digit integer, like single integer, not single digit integer. Single integer is what we have to. Next thing is, now we'll just look into an example here. So to look into an example, we'll take the first example itself here. We'll go. Okay, so max total, I'll write the question name. Max total from optimal activation order. Now this is done. I mean the question is done. So yeah, we'll just take one example. A first example they have given value, the array value is having the values 3, 5 and 8, and limit has the values 2, 1 and 3. So what we can do here is, we'll just write the exact same column as they have written in our this one, what the Leetcode question, the step, and then activated I, and then value of I, active before, again I, and then active after. I, and this is becomes inactive. become inactive. This is J. And then we have two more columns, which is total and inactive elements. Inactive elims. This is becomes inactive. Become. Yeah. So this is exactly the column they have given for us in our Leetcode page. Now the first step will write step 1. Activated as the first one. We'll take it as 1. And the value is 5. I value 1. It was 5 here. So we'll take 5 here. So it was not active before, so we are gonna take it as 0. And it becomes active after, so 1 here. Here what we'll do is we'll take j is equal to 1 and limit of 1 is equal to 1. Limit of j, sorry, limit of 1 equal to 1. And then here our inactive element is 1. So what is the total here, guys? The total value here is 5. Now in our second step, what we'll do is we'll take the activated as 0. So our first value is 3. So it was not active before 0. And then it became active afterwards, so 1. And here there won't be anything for it because it was the first one. And now it became an inactive element 1. So the total here is 8. Now the third one will take 2, which is 8 here. So the value is 8. And it was active before, yes. It became active after, so 2. So what we will do here is we'll take j is equal to 0 as limit of 0 is equal to 2, and this will become 1 comma 2, and the value for this is 16. So the max total here is 16. So the max is 16. We'll return the max value, which is 16. I hope everyone are clear with the question, guys. If anyone has any doubts, please put in the comment section. I will directly go to the approach for this question, guys. First one is we have to pick and sort. We'll write it as pick and sort. We'll make tuples, whatever you guys call. Make tuples. What are the tuples? Value, limit, and index. Okay, it's value, limit, and index. I'll return as val, lim, and index. And then what we'll do is and sort them by increasing order. So increasing order of limit. If limit same, then decreasing value. will be taken first. So yeah, now second step we'll do simulation without banning. Simulation without banning. So for this what we'll do is we'll track elements that are active that are active and the banned ones and banned. Next what we'll do is we'll maintain uh, count of currently active elements. And after this what we'll do is we'll maintain a pointer id index or idx into sorted list to ban elements. As soon as there's a condition for this, this should be done when our active count reach or exceed limit. And then we'll just create an activation loop, a third point, basically activation loop, here done. For each element in sorted order, we'll run an activation loop. This loop will run with an if condition here, which is if our active number is lesser than limit I and not ban. I'm sorry. This is if in this condition what we'll do, add value I to answer and then mark it as active, and increment, we have to increment active NO, this one we have to activate this active NO, and then we'll ban all whose limit is lesser than or equal to active number. And finally, in our last step, what we'll do is return sum. I'll just write the pseudocode, or okay, fine, we'll go to the code of this. Before that, we'll just discuss the time okay, fine, we'll go to the code and quickly return back. So here is our code. We all know n is, and then this is current active, this is permanent ban, and then number of currently active elements is given by active now. This is to keep a track. This is count currently active, and this is our value, activation value. There is our activation value. These are sorting. This sort by ascending, sort, then value by descending. Sort limit will sort limit by ascending and value by descending. Now there's a pointer I was talking about, pointer banning elements, and then this is our activation condition, the if condition for the loop. There's our activation loop, condition, so there's a change in our active count after banning, change in active after ban. This is for banning restricted, ban restricted elements. So this is for if active, then deactivate. If active already, like even before it was active, we have to deactivate them. Then finally we have to adjust our active counts here. And this is our final result. We'll submit this. And as you can see, the code runs perfectly fine. We'll go to its time complexity now and the space complexity. So the time complexity, sorting again, O of n log n, and then single pointer through. For that we have to do single pass, then single pass through the sorted list, and ban, and that banning process we'll be doing ban process. For that we'll use O of n. So the dominant term that is O of n log n, the time complexity is O of n log n. Then we'll go to the next one, our space complexity. Space complexity is storing tuples, tuple, tuple, whatever you call, and also track active or banned arrays. We all know what it is gonna be. It is gonna be O of n. So overall space complexity is also equal to order of n. This n again. Yeah, that's all for this question. So today's contest again, Owing that if it's a tricky question, it's enough. No need to make it difficult. That can be seen in our fourth question of the day. So you are given with an integer n. A number is called special if it's a palindrome. If every digit appears exactly k times. Two condition. We have to return the smallest number strictly greater than n. So if n is given, we have to return a number that is strictly greater than n, which is the special number, which should be the smallest number, smallest special number. So if n is given as 2, then the output is 22, because 22 is the smallest number greater than 2, and it's a palindrome where the digit 2 will come exactly twice. Just a second. So special number, Marcus. Next, last question of the day. Special palindrome. Special palindrome number. So with this, what we are gonna do here is, so yeah, max special palindrome number. Here what we are gonna do is, firstly we'll go for our intuition quickly. First one, palindrome. What is a palindrome? If you read from front and back, it will be the same: 121, 252, 222, 444. These are all palindromes. Now, these are first thing, and second thing is, digit k should appear exactly k times. What does this mean? For example, we'll take a number. Okay, each k should appear k times. What does this mean? So according to this condition, 121, 222, 444, all this are gonna fail as special numbers. These are not gonna be considered as special numbers. But what will be considered as special numbers? Anyone in the chat? I'll give you 5 seconds. Quickly just drop your answers. Okay. So 22 is a special number, 2 and 2. And then what can be? And then it can be 44144. This can be a number. And then what else can it be? And then 333, 9 times 9. All this can be. These are the special palindrome numbers. These are the numbers we have to find now. So yeah, what are the key observations we see here? Limit digits are limited in special palindrome. Digits limited. So, which means total count of digit equal to sum of all distinct digits. Yeah, which is, for example, if you take 22 counters and the sum of distinct digits is, or I'll take 212 for better understanding. Count is 3 and distinct sum is distinct sum 2 plus 1, which equal to 3. Now, secondly, what we'll do is the sum is small, since maximum it can go up to is 45, but we have been given a condition which is 10 power 15, so it will need up to 16 digits. If we search for in a 10 power 15 in forward order, it will 100% give us a TLE. So what we'll do here is we'll pre-compute. It is basic. Whenever you see a constraint like 10 power 9, 10 power 12, 10 power 15, first thing we have to do is pre-compute. Pre-compute all special palindromes at once. At once. And then what we'll do is sort them. We'll sort them. And once we are done with sorting, we'll apply binary search. And binary search, where we'll find smallest which is greater than our given n. So yeah, this is basically what we are gonna do here. We'll go to our approach quickly. First, generate all valid digit sets. Generate all of them. We have to generate all valid digit sets. What we'll do is we'll choose subset of digits 1 to 9, because if 0 comes it will break the rules. So 1 to 9, and we have to ensure that count of digits is lesser than or equal to 16, which is our limit. This is because we have been given that 10 power 15 is the max value of n. Sorry, 10 power 15 is the maximum value of n. First step done. Second step, we'll check palindrome feasibility. Palindrome feasibility. For this, what we'll do is, for the first half of the palindrome, we'll take each digit k. We'll take each digit k, first half, digit k that is repeated k by 2 times in the first half, which means that we can have max one odd set only, one digit odd. For example, 2 and 2 or 4 4, wait, 6 6 6 3 6 6 6, something like this. This is what we can have. And then third step, will generate permutation. As I said, first stuff repeated k by 2 times. First half of palindrome. Sorry guys, for checking the palindrome feasibility, I just made a mistake here. We have to see that odd count is 1. Odd digit count equal to 1, which means we can maximum have one digit odd. And here in our generate permutations, first half of palindrome, we'll check for k, digit k repeated k by 2. Which means that if we take a digit 4 in the first half of the number, it should be repeated 2 times. Now we'll permute the half, and after that, if odd digit, put in middle. And once we are done with this step, what we'll do in this step itself, we'll append the reverse of first half. Append first half reverse. So yeah, and then in our next step, what we'll do is step 4, we'll store and sort all such palindromes. Store and sort all such palindromes. And last and the final step, Well, you might be aware of bisect, right? In Python, we'll use bisect, right, to find smallest palindrome. That is strictly greater than n, which means that if you are given with the number n is equal to 22, then you can't write 22 here. 22 is not considered a special number. The special number n is equal to 22 means the special number is gonna be 2 and 2. Mostly, if I'm right. I don't have any interpreter in my mind. I'm just trying to calculate and say most probably it is 2 and 2. Now what we'll do is we'll go to our code quickly. Yeah, these are limit, which is for 10 power 15 is there, so 16 is taken. Then this is our max length we need. This is for valid combination generating. Valid digit combination. And this R is for choosing our subset size. And then we have to count odd occurrences. Count odd, and it is valid only if at most is one odd number, which is if odd smaller than 2, which is already combined within this. Here the condition is given on mixed both. Then this is our total loop where we build the left half and right half. Left half, and then this is reverse appending reversed half. And then finally this is to store and increment n. Store and increment. This is, we'll simply write store n. Store our palindrome. And then this is for sorting. Now finally we'll use bisect, right? Binary search to find our smallest palindrome greater, okay, strictly greater than n, strictly greater than, which is, it can't be equal to strictly greater than n. And what I'll do now is I'll submit this code, and it is the most perfect code written for the fourth question, and it beats all the given submissions at this point of time. And it is the fastest submission basically. So we'll go to our time complexity and space complexity. Time complexity, uh, 1 to 9. So we have 2 power 9 possibilities, which equal to 512 possibilities. Subsets for pre-computation. This is pre-computation. And then for subsets, for each subset, max we generate is 8 digits, because we'll be as I said, we'll be dividing into half, first half and second half of palindrome. And then what is it? So palindromes generated is in thousands, number is in 1000. So it was manageable, and it was actually, since we are pre-computing, it was very fast. And then we'll go to the we'll go to our space complexity. Anyone in the chat, what will be its final time complexity? Continue it further. I've just told for pre-computing phase. Continue it further and say what will be its time complexity. Okay, fine. I can't see anyone in the chat, so it is gonna be a O of 2 power 9 into 8 factorial, which equal to O of 512 into 512 into 40,320. Well, directly go to this and find our simplified time complexity. I don't want to make it complex. Server is too busy. Just give me a second, guys. I'll calculate and tell you guys the final time complexity. Okay. So this is gonna be ours. O of 2 into 10 power 7. Again, O of anything. We'll try to generalize this now after. And there's a pre-computation. Next is for query phase, which is O of m log m, but m is a constant here. M is constant. Therefore, this will go to O of 1. Query stage will be O of 1. And then binary search. Within this query, we have binary search. O of log m. But again, m is constant, which will lead us to O of 1. Now we'll try to generalize all of this. So, if we say that digits up to d, digits up to d and limit L, we are gonna get a time complexity O of 2 raised to d into L by 2 factorial. These are generalized time complexity, but for this question it is gonna be O of 1 when we simplify everything. So because we are known with the constants and we can calculate. So yeah, and now we'll go to our space complexity. The space complexity for this question. For sorting we are using O of m, which is a few thousands as we discussed. Again, if we simplify, we'll take m as a constant, then it is gonna be O of 1. Since we are saying that O of m will be as few thousands, with that it's gonna be O of 1. And extra memory for generating permutations is gonna be O of h, will take it as extra memory. Anyone in the given constraints, what gonna be its fixed memory complexity or the space complexity? Anyone in the chat, guys, what is gonna be its final time complexity and sorry, the space complexity? Just a second, I made a small mistake while calculating. Remove this O of h, will reduce it to the constant time itself. Now, extra space for generation, it is temporary arrays and the length is less than or equal to 8 for permutations. Tuples or temporary arrays, which is less than 8. So this will lead us to a time complexity of O of 1. So the final time complexity of this with given time, with given all the constraints and all, is gonna be O of 1. If you want in a generalized form, it's gonna be O of m. In a generalized form, it's gonna be O of m. So yeah, I hope all the 4 questions are clear for everyone. If anyone has any doubts, please put them in the comment section or wherever. My LinkedIn is also there, so you can send me a message even there. So that's all for today, I guess. I hope everyone are clear with it. With this, we are gonna end today's live stream. I thank everyone who joined. Please like, share and subscribe to the YouTube channel. And we'll meet on the Wednesday with the Coach F starters 199 or 200. I guess it's 199. Coach F starters 199. We'll try to meet on Wednesday. Until then, have a good time, guys. Have a good day. Enjoy and keep solving the different kind of problems. Thank you once again. Like, share and subscribe to my YouTube channel. I hope you all enjoy today's live stream, guys. So yeah, Until we meet again, it's me signing